The next topic that we're going to talk about are functions. So when talking about a function, it's probably good to start with the definition. So first thing, we need the definition. A function is a relation from a set, which we're going to call D, to a set, which we're going to call Y, that assigns each element in D to exactly one element in Y. So I'm going to underline this exactly one because that's the most important part. So what is a function? A function is, you can kind of think of it like a machine. A function takes something from its domain, which we're going to call D here. It does something to it, and then it spits out something else, which is going to be in Y. So the exactly one part means that every input has exactly one output. So if you want to think of a picture of this, maybe here's my set D, over here is my set Y. F is a machine that takes something from D, puts it into Y. So it'll take like this element X over here, and it'll map it to, let's call it little y, or f of x. That's what f does. In this example, x is your independent variable, meaning I'm free to choose whatever x I want in this set, and y is your dependent variable. So why is it dependent? Well, that's because y depends on what x I chose. So depending on what I choose over here in my domain, that's going to tell me what my output is. So a couple examples of this. Let's say I have my domain here. My domain has the numbers -1, 0, and 1. Then I'll have my other set y here. I'm going to have f going between the two. Y is going to have the numbers 2, 3, and 3.1. Let's say that -1 goes to 3, 1 goes to 2, and 0 goes to 2. The question is, does this represent a function? So for every input, so every one of my independent variables, do I have exactly one output? Well, let's see. What's the output for -1? -1 went to 3, so the output is 3. What's the output for 0? 2, so yes, that's okay. What's the output for 1? Also 2. That's okay. So yes, this is a function. And the way we could write this is we could say f of -1 equals 3. F of 0 equals 2. What was f of 1? 1 was mapped to 2, so also equals 2. One thing I do want to mention, it's okay that I had the same output, I just can't have the same input more than once. So, let's do another example. Here's D, let's say that I have 1 and 0. Here's my set y. F is going between the two. Let's say that y has the numbers 2 and 3. Let me draw the picture here. Is this a function? Let's see. What is 0 mapped to? F of 0 is 2 because 0 is mapped to 2. What is 1 mapped to? Well, it's not clear because 1 goes to 2, but 1 also goes to 3. So because this 1 is going to more than one thing over here in my set y, this is not a function. Because what is f of 1? Well, I don't know. F of 1 could be 2 or f of 1 could be 3. Not really sure. F of 0 is well defined. That's going to be 2. But f of 1, not well defined. So this is not a function. So the next part that we're going to talk about for a function, now that we know what it is what is the graph of a function? So a graph of the function, this is found by plotting points in the xy plane. So the graph is found by plotting points in R2 or the XY plane or the Cartesian plane. I think we've already talked about this. Any one of those you can call it. So for example, let's say I want to graph f of x is x squared plus 1. Let's say I want to graph this by plotting points. I don't want to graph it explicitly, I just want to plot some points, get a general shape of it. So what I'm going to do is figure out a bunch of points that satisfy this function. So maybe I'll make a table. I'll have my inputs and my outputs. These are my independent variables, my dependent variables. So let's maybe plug in 1. If I plug in 1, what do I get as my output? Well, 1 squared is 1, 1 plus 1 is 2. So 1 squared plus 1 is 2. What do I get when I plug in 0? 0 squared plus 1 gives me 1. What about negative 1? Let's do some negative numbers. This will be negative 1 squared plus 1. You want to be careful how you plug in this negative 1. Well, negative 1 squared is 1. 1 plus 1 is again 2. How about 3? Let's see. 3 squared plus 1. That's 9 plus 1, so 10. And then lastly, how about negative 3? That'll give me negative 3 squared plus 1, also 10. Now let's plot this and see what I get. Here's my x-axis, here's my y-axis. So one point that I can plot is 1, 2. Here's 1, here's 2. There's 1 point. How about 0, 1? 0, 1 will be right there. Negative 1, 2, right here. 3, 10. See, 10's probably way up here. And then negative 3, 10. Probably like that. So if we were going to sketch this graph, we would say it probably looks like that. And let's label this so we know this is f of x. So that's going to be my curve. One thing that we do want to ask is what is the root of a function, and also how do you know if a function or if a graph is a function? So different definition. The 0 or the root of a function is x values. There might be one, there might be more than one, such that f of x equals 0. So the zeros of a function are just those x values, such as the function equals 0. That's going to be what a 0 or a root is. So for example, let's find the root of f of x, which is x squared minus 4. So to find the root of a function, what you're going to do is set it equal to 0. So I'll set f of x, which is x squared minus 4, equal to 0, and now solve this for x. So I can move 4 to the other side. Now take the square root. You want to be careful. There's more than one square root of 4. You get plus or minus 2. So the roots, or zeros, whatever you want to call them, are negative 2 and 2. Now why do we care about this? Why is this related to the graphing portion that we were just talking about? Because roots are where f of x crosses the x-axis. So if I were to graph this f of x that we've been talking about, so 2, 0, and negative 2, 0 are on the graph of f of x. So roots and zeros, whatever you want to call them, those are where f of x crosses the x-axis. So in our example, f of x is going to cross the x-axis where x equals negative 2 and where x equals 2. So that's what zeros and roots are. Lastly, how do we know if a graph is a function? I'll go to the next page here. So a graph is a function if it passes the vertical line test. So the vertical line test comes from the fact that for any input I can only have one output. So what this means, say I look at this graph real quick, any x value that I have, if I look, there's exactly one value of y associated with it. So that means any vertical line that I draw, doesn't matter which vertical line I draw, it passes through the curve in at most 1 point. So you can see this vertical line passes right there, 1 point. This vertical line passes through 1 point. So this passes the vertical line test, so this is a function. Alternately, let's say I look at this graph. Let's draw some vertical lines. Now this vertical line, that doesn't pass through the curve at all. So that passes through 0 times. That's okay. I just said that it has to pass at most once. But what about this vertical line? Passes once, twice. As soon as I get something that's more than one, this is not a function. So not a function. And again, what this is coming from is that whatever x value this is, it's associated with 2 different y values. So that's the exactly one part that we were talking about before. So there's kind of the introduction to functions and the graphs of the functions.